What's up, everyone? It's your boy Drew here, and welcome to Bits and Blocks. I've been super crazy in the past few weeks with all kinds of AI trend and also implementing new features for the Oraichain ecosystem. And now I finally have some spare time to talk with you guys and also share my knowledge about blockchain, AI, all kinds of stuff. I decided to start a new series, which is called Code with Me series. So essentially, the series will be me implementing some features or some tutorials, and I would guide you through the process and explain how I understand the feature technically, and also understand the context. And basically explaining the context behind it. And I will share it whenever possible. And I hope that you guys like this series. So before we start, make sure to hit like, subscribe, and hit the notification bell button. And let's get to it. Okay, so let's do this. Here we have our Oraichain MCP server, which is a repository for maintaining some Oraichain MCP related tools, where you can contribute and implement some tools like querying balances, wallets, staking, delegation, all kind of stuff. So here are the prerequisites for you to install and also set up environments for the repository. And here's how you install the repository by using Node.js and also pnpm. Personally, I find that pnpm is really easy to use and manage a mono repository with different packages. And if you look at the left, I am so basically I was interacting with the repository by cloning and checking my environments, my Node.js environments version before I can start installing the packages. I'm scrolling down to show you the project structure. We have an agent kit repository, an agent kit package, where it includes all necessary functions and methods for you to basically interact with the Oraichain network, get delegation, get balance, and also some utility variables and instances for you to sign transactions and handling and passing important and crucial data and arguments. Moving on, we have agent tools, which include all kinds of MCP tools. In here, you define a structured tool. Here, I use LangChain tools, which is a very good type that can work well with different MCP servers. And to to build a tool, you need to extend it and add some necessary instances like name, description, and schema. And then after that, you implement a function call. In there, just implement what you need to do. In here, the transfer tool, right? Implement like a way for the agent to create a transfer transaction from one wallet to another. And here's where I show how I would test the tool by writing some unit tests using vtest. And after writing the test, I would start moving on to the last package, which is the MCP server. So essentially, the MCP server is the aggregator of all the tools that I want to include, and it will be the entry point for the MCP client to connect to and to expose all kinds of tools out there in the public. And personally, I don't really like MCP STDIO as much, since STDIO MCP server is used for local and desktop applications. Uh, for the desktop MCP clients like Claude Desktop, Cursor, Windsurf, etc. Personally, I really like the concept of agent as a service, where you deploy your agents onto the cloud and also the MCP servers, and after that, I can like serve the agents as a service to the end users. And so that is the whole point of developing and building AI agents. I don't really like the concept of serving agents to only developers and to like retailers by installing some kind of like applications on the desktop. I don't really like that. But so, which is why I prefer the server-side events standard uh, over like the STDIO. Since with the server-side events standard, it exposes an endpoint and a socket for like other applications and other services to connect to via HTTP, and it's like much more convenient. And we don't really need to care about what languages that the server is implemented. We just need to connect the components of the MCP client and the MCP server via like HTTP. That's simple as that. In case you're wondering where my clock is, it usually stays in the back when I record, but now it's gone. So we are about to move, and we can't, and we don't really want to like keep the clock and bring it all the way to the next place that we want to leave. So we just like get the clock away. So. Okay, let's get back. Right now, I'm going to show you how you can like implement a tool and quickly integrate it into the MCP server. Uh, the tool that I am showing you is AutoCompile. So imagine where you can ask your agent to like automatically claim your rewards from staking on Oraichain and auto compiling it into your validators. It will save you like lots of time integrate like interacting with the UI, and also like doing like multiple steps to like collect the rewards and then create another transaction to delegate to the validators. Imagine you have like 10 validators, you would need to like manually doing it like 10 times. uh, and if you are like a developer, you can like create a script, right, to do like automation. However, for like normal end users who don't know much about coding, the auto compound tool feature is like really convenient. And here I am like implementing the basic logic for like querying the total number of delegations that a wallet has, and I'm trying to like query the rewards from these delegations so that the agent knows how much or like how many tokens that it should send and like like for example like do auto compound to the validators. Here you can see that I am trying to like get the claim rewards from the list of validators. Why do I do this? The main reason is that if the wallet has like lots of OI tokens and I really don't want to spend them to put everything into the validators, I just want to like do auto compounding from the rewards to put the exact amount of rewards into the validators, not like the entire like life saving balance of OI that I have. So that is the reason why that what I'm doing here is to like get a list of claim reward messages. On the Cosmos ecosystem. Each transaction can contain like multiple messages, and each message will be executed like sequentially. For example, if I want to claim rewards from the validators and then stake them right afterwards, I can create like a bunch of like, claim reward messages and then push them into an array. And then after that, I create like a bunch of stake reward messages, as you can see here in the on the screen. And then I also push these rewards messages, these stake rewards messages into this list. And finally, the entire like list of messages will be included into the transaction, and then we would sign it. If like you are wondering how the agent manages the wallets of the users, this demonstration is only for like the local version of the AI agent and using the tools. It means that you will need to like import your mnemonic or your private key into the MCP clients that you are using locally, for example, Claude Desktop or like Cursor, and then the agent will recognize and will be able to use that wallet via the tools within the package agent tools. Uh, if you notice on the agent kit repository, there would be like a function to sign transactions using the wallet that you put into the MCP server, and it will be able to sign and then broadcast the transactions using that wallet. So let's get back. Right now, I am trying to set up the finalizing step of broadcasting transactions, and at this moment, I got lazy, so I don't really want to write like a bunch of tests because it would take like so much time. So I just ask like Cursor, like, hey, please write me some tests and remember to cover edge cases. And and right now, yeah, I was just like doing like 5 coding at this point. After finish writing the test, I try to like build and using the command pnpm build, and then as you can see, we finally got it built successfully, and let's try testing it. But oh wait, uh, there was an error. Yeah, at this point encountered this error before, so I knew how to fix it. But like during the first time of implementing like MCP servers using TypeScript, I like basically it took me some time to like figure out like why um, the the MCP server didn't work with, for example, Claude Desktop. And yeah, it was like painful. And hey, don't take screenshots. Don't use this mnemonic. It is just like a test mnemonic that I generated locally. So uh, if you try to use it, uh, you would like lose your funds. So don't. Okay, so right now a bug is fixed, and I'm trying to test if the auto compound script works. Hopefully it does. You usually it won't work for the first time. Engineers, we like never expect something to work on the first time. If it does, then it would be like a miracle. Usually there would be like some bugs along the way, and we would like need to fix it in some like small iterations before the final like production weight version is launched. So yeah, as you can see, we got some bugs, and at this point, I did not understand why it happened, and it took me like basically it took me like half an hour to identify the exact reason. So the bug says that it cannot like unmarshal to dot 13 something plus 29. So I figured that, hey, it may be because there was like some kind of like floating point numbers here, but I was so wrong. At this point, I guess that my brain was kind of foggy for some reason, and I could not like understand why it happened. And it took me about like half an hour to finally fix the problem. And if you can see here, the problem is not like directly visible, and I could not understand why the number was like that high, like plus 29. Uh, it means that the final amount after fees is like way too high. Plus 29 here means like it's the power of 29. And yeah, uh, it doesn't make sense since I did not like have like that much amounts of Ori tokens to like do auto compounding. And here I'm trying to like understand why. And after back and forth, reason was that I was using the wrong uh, class to say like how to say, I was using the wrong class for creating the amount to delegate Ori tokens. Uh, if you notice, I was using the deck coin. So essentially, the deck coin automatically multiply the amount after the decimal uh, to make it like a complete like new number, uh, which is a big int number, instead of just like truncating the decimal points afterwards. So here you can see that I was trying to like do a query locally to see if the balance matches with what I am getting. They look match, but with slight uh, differences, and I couldn't understand why the total amount of rewards can be like that high when I used it in my MCP server. And like I've just explained, it was the Decoin class that caused it. And I rarely used it, so I did not like really know the side effect of that class. So yeah, so yeah, here I was like struggling like very hard, uh, and yeah, it was like a very silly mistake, but a very good like lesson learned from this is to like truly understand what you are using and what you are writing in your code, instead of just like blindly using like some libraries or some classes that you don't really understand. Yeah, here the Cupid is the decoin dot from partial. It will like automatically multiply with the total number of decimals that are like behind the figures, so that it can transform it transform the value into like another number that doesn't have like any like decimal points. And yeah, I was like printing the console log like crazy. Yeah, and after a while I finally understood the problem, and I fixed it by changing the class into like a simple coin method to convert the amount to the correct like balanced amount format for submitting the transaction. And finally it passed. After a while I finally fixed that bug, but like another minor issue came up, which is like I forgot to handle the decimal points after. So as you can see, there is like a remaining like 48 after the number, and yeah, I just like needed to remove it. and then voila, we finally got a result. And give me some drumsticks. Yeah, and we finally got it. And you can see here, the Claude Desktop will automatically sign the transactions and then broadcast the transaction onto the network, and it will also give you like a very detailed result and transaction info after the transaction, so that you can like actually verify if the transaction like is successful or not. And you can see here with the results. And yeah, thank you for watching this tutorial, and it's been a blast doing this, and I feel like very great by like just like implementing and recording this tutorial for you guys, since I feel like very helpful. And please let me know if you want me to like do a live stream coding instead. It would take like longer, for like I guess like more than an hour or so, since I cannot like edit like the entire thing out. And but yeah, doing live stream is kind of fun, I think, since I can like interact and talk with you guys, and yeah, and share my knowledge along the way while like, coding. So please let me know. And yeah, thank you for watching. Please hit like, subscribe, and share this video if you think it is like helpful. And yeah, I'll see you guys in the next video. Cheers.